Okay, so we have a multiple choice question here that says, which of the following changes would cause the reaction below to shift in the forward direction to re-establish equilibrium? So we have something in equilibrium, and we're going to disturb the equilibrium by doing one of these things, and we want to see if any of these changes will cause the reaction to shift in the forward direction. All right, so let's think about each one. So first of all, adding a catalyst is our first choice. That is not going to make a difference just because of the nature of what catalysts are and what they do. Catalysts help a reaction get to equilibrium faster, but otherwise they do not affect the equilibrium at all. So adding a catalyst to a system that's already in equilibrium, it says, to re-establish equilibrium. Well, this isn't going to disturb the equilibrium at all, because if it weren't at equilibrium, then it would help the reaction reach equilibrium faster, but since we're already at equilibrium, it has no effect at all. Okay, so the next one, adding argon. Well, again, it may not be super obvious, but argon is not part of this chemical reaction. It plays no part in this chemical reaction. So adding argon also is not going to affect the equilibrium at all. Only if we adjust one of the concentrations of these participants in the equilibrium will we disturb the equilibrium. C, increasing the total volume of the container. All right, so let's think about a container that we have. Let's say it's about that size. And let's say that we have these little gas molecules flying around in there. And so then what we're going to do is we're going to increase the volume of that container. So now it's bigger, okay? We just like a piston head or something moves up. And so now those four little gas circles are spread out more, all right? And remember Boyle's law. This is again another one of our Chem 1 review topics. According to Boyle's law, if we increase the volume, then the result of that is we decrease the pressure, because pressure is the amount of collisions these gas molecules are having with their container. Well, if the container gets bigger, then they're going to collide with the surface of the container less often. So increasing the total volume of the container is going to decrease the pressure. All right, now that's not really going to get us to the answer quite yet. We also have to think about something else, and that is the total moles of gas on each side of this equilibrium. So on the left side of this equilibrium, we have 2 moles of gas, okay, just 2 moles of the nitrogen tribromide gas. But on the right side of the equation, we have 1 plus 3, so we have 4 moles of gas on the right side of the equation. All right? Well, it's going to be a lot easier for nature to fill this void with 4 moles of gas than it can with just 2 moles of gas. So if you expand the container, lowering the pressure, it's going to cause a shift in the direction with the larger moles of gas. Okay, that's the rule. When you have gases involved, if you do something that decreases the pressure, the equilibrium will shift in the direction that favors or that has the larger number of moles of gas. So it looks like C is our potential answer here, but let's go ahead and talk about D. So D says adding N2. Well, adding N2 would be like stressing that term right there, which because we're stressing the right in a positive way, it's going to shift to the left, which is not the forward direction. That would be the reverse direction. So D is not correct. So as we thought, C is the correct answer.